Okay, thank you very much for listening to my PhD talk. I'm very pleased to kick off this knowledge sharing session. My research is on the quality aspects of AI-enabled systems. My name is Merel Veracx. I'm from the Fontys Applied University. My expertise is IT architecture, software engineering, AI engineering, and more recently also generative AI, and how to enhance software engineering with those kind of things. I'm going to talk about quality criteria. If we continue building software and more things are being replaced or enhanced with AI, whether machine learning, whether generative AI, whether reinforcement learning, for example, what do we need to monitor and how to make those systems even a good success? I did not expect the screen to have this kind of contrast, but no, it's okay. You don't see what it's really about here, but a recent publication about published in TNO has a generic framework on how to model a whole system with certain AI aspects. And for me it's very relevant because AI is becoming more and more mainstream, and when we now describe systems with some kind of AI components, we don't really know how to model those things. We talk about them, we see them working, but the documentation is not always very straightforward, where the component is being trained, on what kind of data, and how maybe the component is automatically retrained with online learning. So this is my focus. My focus is on system engineering with, for example, here, a model deduction, for example, in a whole body of and of course, data is used to automatically infer rules or automatically behave. And so it's not only programming the rules explicitly, but deducing them from data. Yes, thank you so much. I've been doing this for quite some time now. I think if you press again, I had some very interesting errors that are coming down. So one of the errors is splitting the screen in half, because I'm currently at the middle of my research. Funding is underway for the next 3 years, and the scope of my research has been scoped very well. I've been doing some research on quality and priorities when we engineer trustworthy AI-based systems. I've done an interview study. The results has been presented to the research community. It has not been accepted, but it was a very good learning experience. What I did indeed achieve, and that's also something that I really need for my motivation, is an accepted doctoral plan on the Kane community. And if you go to the next slide, you see me. No, you don't see me, but this very opaque person refusing to look at the people in the room. That was me presenting my plan at Kane community in Canada. So I had the opportunity to really talk to other researchers, software engineering, AI engineering, what is it that we need in quality, in IT architectures, and how to scope this research to be proficient. I'm going to present some preliminary results to you that I also showed there, but I also want to show you what I've been discovering in my interview study the past 2 weeks. So, first and foremost, I'm, well, not anymore, but I'm mainly an educator at the Fontys Applied University. So I use the student projects and the companies that we have contact with to learn about what they find challenging or what they know how to deal with. Those lessons learned have been analyzed, and one of the most important quality criteria that was rediscovered because it was important already for 20 years, is we as software engineers need to embrace change all the time. Everything changes, the data changes, software libraries are changing, even the customers are changing. Those changes are being changed themselves because of AI. The data and the model introduce new kind of changes. We see that because of ML ops engineering practices. We see the emergence of data ops practices. And also the software integration, the human in the loop, the explainability, all new topics that need to be incorporated into your IT architecture. So I'm going to show you later on a sneak preview how to support, and the technical term for embracing change is modifiability. How to embrace or support modifiability with 3 architectural perspectives. So I as an IT architect, we know how to model big systems, document architectural design decisions, but how to integrate them into existing practices, like, for example, TOGAF. Last but not least, I'm going to give you a too much detailed slide about my research methodology, but at the core, it's an invitation for everyone who is experimenting and having production systems to just contact me, because I can learn a lot from you, and I also begin to feel that I can give a lot of knowledge back. So tips and tricks and how others are doing it. Thank you so much. I started with an interview study. The core interview questions were, what are the challenges in integrating machine learning in your software systems? And which are your top priorities when it comes to quality? Is it mainly the software quality, or is it more data quality? Is it more model quality? We had in scope that we have our very normal software qualities like modifiability, maintainability, scalability, but also the model qualities, model correctness or model robustness. And in the course of those interviews, we also saw that data quality, what demand is about, was very, very important for all our partners. Data timeliness, so it's okay that we have an MRI system somewhere, but the data needs to be in the dashboard before the end of the hour if we want to monitor a certain patient. Things like that. I've interviewed more companies, but in the end we selected only those companies with mature systems. I had 5 interviewees, and we realized in the course of the analysis that within those companies and within those stakeholders, that over 18 different projects were being mentioned. So each one of us working in a company has a lot of things happening in terms of change. I can share my fantastic paper with you. I show here 2 snippets of results. The first one, who goes on 18 times more, is about for each company, sector and role, which kind of projects have been realized in the past and are being planned in the future. For example, they started out with a visual fault detection in product manufacturing with, as a model, anomaly detection. They realized, delivered that, and then the next step was, okay, we now need to have a distributed machine ML ops learning environment, because our context is that we have our manufacturing production lines and they change. They change every 3 weeks, 3 months, yearly, and we don't want to have the AI engineers retraining the anomaly detection. We really want to have the operators having those tools at hand to do it themselves, and that we can offer our expertise. An example of changing requirements. There's also a very nice overview of all the challenges. What I did is classify the challenges into different steps. For example, the data science methodology, you have business understanding, data exploration, and so on and so on. So I classified all challenges, but also classified them in terms of quality requirements, freedom from risk. How many times is something like that mentioned? So each organization is approaching their integration challenges in a different way, and they all choose a different quality as a primary focus. That was one thing that was very apparent across those small selection of projects. Two things that we established: AI systems can only bloom successfully with a solid data foundation and stemming from flexible software. That was one conclusion. And we proposed to update the AI engineering definition, more or less the MLOps definition, with data ops and DevOps. So those three lanes are now being presented as occurring and being performed by different roles and persons, but we see in practice that most of the time the developers are switching from one role to the other. So, as I said, it remains a fact that most of the cost of developing software system occurs after the initial release. So we and I am going to focus on the continual change that our system needs to do with an AI component in it. And the term is modifiability, but of course we have a lot of other quality criteria that always intersect with modifiability. And it's about the evolution of your IT system. How am I doing about time?
I don't know how much slides you have more.
Too many.
You have 10 minutes.
Oh, then it's good, You can continue on to the next slide, because if we have an overview of the current state of our workflow, our actors, the different data sources, the different machine learning or AI components in it, then you can quickly see that each system has changes being introduced by, and we've called them AI teams. Data, model, model inference. I was at a conference in Canada. One of the things that they were stressing is that the time when you have only one model in your system is just past. So you have some vision models doing specific things, you have a reinforcement system who was calibrating all kinds of workflows and decisions, and then you have a conversational agent, an LLM, who gives you access to the backbone. So only one model, as was most common in 2001, is possible. Yes. To illustrate, based on my literature reviews, my literature study, the interviews, we see a lot of teams that introduce change. I've already mentioned human-in-the-loop practices, not only explainability, but also having the chance of correcting or bypassing or whatever, doing things with the result that the AI is giving you. New deployment practices, the edge is becoming more and more relevant. The democratization of AI engineering techniques. You needed to have someone like me with a master in artificial intelligence before to do the stuff, training a model. Now I have my daughter that is just using something from the internet and tells me, "Mama, your food is bad," because I've taken a picture. So we need to deal with that. And of course, new AI components and the data. New data, new updated data, data shifts, data quality, all those things are also happening with your whole system. That brings me, I think, to my research. Yes. So the past 2 years I've made an exploration of the field, of the challenges, and I really went back to my roots and said, okay, what do I like about software engineering? And it's about architecture. So having an architecture and really reasoning about what is the next thing that I want to change in that architecture to really reach a certain strategic goal, that's what I want to focus on. And so that brings me to how to support the evolution of AI-based systems. Knowing that the change stems from 3 different directions: the integration into the software data or your different models, and then how is this influencing the team, the process, how do the users need to work, but how does the software or the data engineer or whatever needs to work, and how does this translate into the whole body of tools, infrastructure, and software. I'm going to show each of them because I already did a lot of work in it. So I'm going to show you how I'm going to classify or describe the changes, and then I'm going to show you 3 examples of those views, and I like these the most, so it will also not be very visible, but I'm going to, I think we can fix that. So the next step is a creation of a change catalog. A lot of work has already been done in that part. In software engineering, you have a software architecture handbook written, among others, by Kasman, and they defined quality scenarios. And I'm currently extending that body of knowledge with modifiability for AI-based systems, how to describe it. So all my interviews, I'm going to structure them in such a way that you see what is the recent change, what was the event that motivates the change to the IT architecture, and also feature current state and what has changed. I hope to see patterns emerge across sectors, across disciplines, where normal steps to take become apparent. Yes. The framework that I'm going to use for my perspectives stems from fairly old publication, 1992, from John Henderson, about strategic alignment, business with IT. It has a very 80s, yes, huh? Yeah, I see some of you smiling, yeah. But the principles remain the same. Whichever IT architecting model that you see nowadays, if it's UML, if it's TOGAF, it doesn't really matter. All those different parts are there, are being not always explicitly described, but are there. And I'm going to select 3 views from it. So if you click it, then I have a very cool overlay. So my teams and organizations are at the top, the process at the bottom, and then, yeah, Petra saw my presentation Tuesday, and then my purple box was stopped here, and I'm still thinking that I need to enlarge it, but work in progress. Now, what does that mean? What does it mean to have a holistic framework to model the evolution of your IT infrastructures to embrace AI components? Well, for teams and organization, I have a very small, oh no, sorry. The process view can look something like this. It's work that we have been working on for the past 2 years, so it's also the most complete. I already mentioned it, that one of the first conclusions of the interview study was that you not only have your AI engineering, but also your software integration engineering and your data engineering, and that those processes seem to happen in parallel, but a lot of communication in between is happening in practice. Yeah? Maybe not in a formalized way, but it is happening in practice. That's one example. The other example is very much work in progress. This is based on 3 papers for now. But you also see that for DevOps, we know these roles. But in data ops, we in practice at our school, we realize that no project can really lift off with students if you don't have the domain expert at hand. And also being more and more relevant, privacy officers and also ethics committees. You see those roles, those groups forming real time at organizations. And then the last one.
Yeah.
And now I need to become a bit tech savvy. This is research based from the Hogeschool of the University of Amsterdam, from Patricia Lagou. They analyzed ML ops architectures, and what I've been doing is extending that with data ops and workflow components, AI integration models. So it's still work in progress, but for example, you can see it, no? No.
More or less.
Sort of.
Dear God, the setup is no. So what they did is to analyze all literature, put it all together, make a classification in optional components and mandatory components, which I found is already a bit biased. But everything in bold is things that I've found in literature in the same methodology, using the same methodology that others are adding to their architecture. So in manufacturing, one of the business owners was saying, okay, we can't really work with our data suppliers because no ontology is there. And we need to reinvent the wheel every time that we want to integrate something. And it needs to stop because that will not help us much further. I will not, due to time, he was starting to panic. I'm going not to explain it in more detail, because I want to end my presentation with my research methodology. So you've seen already that I mentioned that I have an inventory of literature. It is changing very, very, very rapidly. So each week I have 10 new publications in my email. We have a classification of changes. We are going to validate not only those changes, but also the IT architecture, modifiability practices with the Dutch high-tech region, with software engineers. And if you want to participate, please contact me. So thank you very much for your attention.